I'd like to talk about scientific notation, and I'd also like to give some specific tips on using scientific notation with your calculator. So in chemistry, we often deal with very large and very small numbers. As an example, we're often interested in how many atoms or molecules are in a given sample. And if we took a 20-ounce bottle of water as an example, the number of water molecules present would be roughly equal to the number that I have shown there. And it can be very easy to leave off a zero or add a zero, plus writing all those zeros is just a really big inconvenience. If I use scientific notation instead, this number would be 1.89 times 10 to the 24th molecules. And so there's no doubt about the exact size of the number because of the exponent that I include in the number when it's in scientific notation. Similarly, we often deal with very small numbers. As an example, the mass of an electron is represented by that number there. And again, writing all those zeros is incredibly inconvenient. It would be really easy to get it wrong, but in scientific notation, I could write it like that. So let's see some examples of exactly how we convert numbers from conventional notation to scientific notation and back. And we're going to use this a lot this semester. Alright, so scientific notation provides a convenient way to represent very large and very small numbers in a very compact and easy to use format. When we write a number in scientific notation, it always has two parts. We have the coefficient, and in our first example on the last slide, that was the 1.89, and then that's multiplied by 10 raised to some power. And the power of 10 is chosen such that the coefficient is between 1 and 10. Right? Another way to say that is, when we write a number in scientific notation, we always have one non-zero digit to the left of the decimal place and only one non-zero digit to the left of the decimal place. All the other non-zero digits come after the decimal point. Now, when you're first doing scientific notation, I find that students often like to sort of memorize, if I go to the left, it's a positive exponent. If I go to the right, it's a negative exponent. I don't encourage you not to do that, because when we're going from conventional notation to scientific notation, it would be one way, but when we're going from scientific notation to conventional notation, it would be the other way. And so I want to encourage you, don't try to use or memorize, left and right for positive or negative exponents. I think the more easy thing to remember, because it works whether we're going from conventional notation to scientific notation or vice versa, is to just remember this. Right? A negative exponent means the number is smaller than 1. A positive exponent means the number is greater than 1. And so if we did a couple examples, here I've given some numbers in conventional notation. I want to write them in scientific notation. So in this first example, this number is less than 1. So I know my exponent is going to be negative. And I need to move that decimal place over. And how many places I move it over tells me the power of 10. So I need to go 1, 2, 3, 4 to get the decimal point after the first non-zero number. And so then in scientific notation, that would be my coefficient, and then I moved it over 4 places, so it's 10 to the 4th. Because this number is smaller than 1, it would be 10 to the negative 4. Right? In the next case, I want to put my decimal point here. Right? It started out here, so I need to go 1, 2, 3, 4, 5. So in scientific notation, I would have 5.16 times 10, and it's going to be to the 5, and because this number is bigger than 1, I know that it has to be 10 to the positive 5. Right, and then similarly, if we look at going from scientific notation to conventional or standard notation, I need to move the decimal place again. And again, I'm not going to worry about left or right. When I look at this number, I see that it's a power of 10 to the positive 8. So I know that this number is bigger than 1. So in order to make this a big number, I need to move the decimal place this way. And I need to move it 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. And so I can kind of fill in zeros here. And so I have 1, 2, 5, 6, and then 1, 2, 3, 4, 5 zeros. and it might help to put in the commas. And so then we can see, double check, right? 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I've done that correctly. And then in this case, I have a negative exponent, so I want this number to be smaller than 1, so I want zeros out in front, so I need to move the decimal place in this direction. 1, 2, 3. And so I have 0.0072 would be that number in standard or conventional notation. So one thing to be really careful of in this class is doing scientific notation with calculations, and particularly how you enter that into your calculator. So take a second and do this calculation and see what you get as a result. All right, if you've done that correctly, you should have gotten 2.99 times 10 to the minus 6, or your calculator might have spit it out in conventional notation, and it would have looked like that. If instead you got 2.99 times 10 to the 10th, what happened is you entered the number in scientific notation incorrectly into your calculator. Right, so what can happen if you just type 1.46 and then do times and then 10 and then a caret and then 3 and then divided by 4.89 and then times and then 10 and then a caret and then 8, your calculator doesn't know that you're trying to enter those numbers in scientific notation. When you do the times and then the 10, it treats the 1.46 and the 10 to the 3 as different numbers. Now if you're just multiplying numbers, it doesn't matter, because order of operations, if you're just multiplying, you can do that in any order. But when you're dividing, you have to be more careful. If you entered it in the way I've described and do 1.46 and then times 10 to the third and then divided by 4.89 and then times 10 to the 8th, it doesn't know that these numbers are together, and so it only divides it by 4.89 and then it multiplies that result by 10 to the 8th, and that results in a number that's off by 16 orders of magnitude. So you get the right coefficient, but the power of 10 is really far off. So one way to get around that is, when you're dividing by a number in scientific notation, you just want to be sure to put it in parentheses. But there's an even better way. There's a scientific notation button on your calculator, and so then your calculator will know what you're talking about. It reduces mistakes, and it requires less buttons to press, so it's actually going to make you faster and more efficient. And so on the next two slides, I have two examples on common calculators and how to put numbers in your calculator in scientific notation. When I do that, I use this example on the bottom here. So let's look at the answer to that one. If we enter that into our calculator correctly using scientific notation, the result you should get is 352. All right, so I know a lot of people have these Texas Instruments graphing calculators. If you have that type of calculator, this is your scientific notation button. It's the EE above the comma there. And so if I want to enter 7.1 times 10 to the minus 5 in scientific notation, what I would do is I would type 7.1 and then use the second and then that EE, and that'll just put an E on your screen, and then no times, no 10, just put the power of 10 that you want. So in this case, it would be negative 5, right? And of course, we don't want to do minus 5. We want to use the negative button. And so 7.1, the EE was just prints 1E and then negative 5. And when you do that, you get the correct answer of 352, right? And you can see the difference. I've done it incorrectly in the first example here, right? I did times and then 10 and then the caret. And so what it's doing is it's doing 0.025. It's just dividing by the 7.1, and then it's multiplying that whole result by 10 to the minus 5. And so we get off by a large amount. This says the answer is 3.52 times 10 to the minus 8 instead of the correct answer, 352. And as I said, one way to get around it is to just put in the commas, or I'm sorry, put in the parentheses around your denominator, and that'll give you the right result, but you've got to put in how many extra buttons? 1, 2, 3, 4, 5, 6, where all 6 of those button presses can be replaced by just the EE. And so I want to encourage you, become familiar with the E button. It is your friend. We're going to be using numbers in scientific notation a lot, and so it's going to make you less prone to mistakes, and it's going to make you faster in solving these problems. So if I wanted to do this calculation, I would do 0.025, then divided by, and now 7.1, the E negative 5. When we put it in the scientific notation using the features of your calculator, it knows that number's in scientific notation, and so we don't get these problems with the orders of operations and interpreting what we're doing incorrectly. Alright, so there are lots of different calculator models out there, and I can't do them all, but I wanted to pick another common model. In fact, this is my favorite calculator. This is the one that I always use. And on this calculator, this is your scientific notation button. And so if I want to enter 7.1 times 10 to the minus 5, I would just do 7.1, and then when I click this button, it does the times, and then the 10 is actually smaller, you can see on the screen, than a normal 10, and I just put in the negative 5, right, again, using the button for negative sign, not minus, and it now knows that this number is in scientific notation, and so I get the correct result. I don't have to worry about the parentheses and the carets and all that other stuff. Right? So use the scientific notation button in your calculators. If you have a calculator that's not one of the models that I demoed and you're not sure how to do it, please reach out to me, and we will figure out how to use scientific notation on that particular calculator.